Dear students, myself K. Lakshmi, working as assistant professor in Narasimha Reddy Engineering College. So, in today's class, you are going to see introduction of feedback amplifiers. So, in the last class, I have already explained you characteristics of basic amplifiers. They are nothing but voltage amplifier, current amplifier, transconductance amplifier, and trans resistance amplifier. Let us see the block diagram of feedback amplifier. So here you can see different blocks: a basic amplifier block, sampling network, comparator or mixture, feedback network, and the input block is nothing but signal source, and the load is connected across the sampling network. So feedback amplifier consists of different blocks as shown in figure. So in each one of these circuits, we can sample the output voltage or current by means of suitable sampling network and apply this signal to the input through the feedback network as shown. At the input, feedback signal is mixed with the input signal through mixture network and is fed to the amplifier. Students, you can see basic amplifier, it can be like any one of its amplifiers. Either it can be a voltage amplifier, current amplifier, transconductance amplifier, or trans resistance amplifier. In general, it is represented by A. So here, it depending upon the type of amplifier, so we can sample the output. So it can be either voltage or current, and this sampled output so will be given as input to the feedback network. So at the output, the feedback signal is combined with the input signal through a mixture network, and its output is applied as input to the basic amplifier. So here we can differentiate two types of feedbacks: positive feedback and negative feedback. If the feedback signal is in phase with the input signal, then it is known as positive feedback. If the feedback signal is out of phase with the input signal, then it is known as negative feedback. Like if we see in nature, negative feedback exists but not positive feedback. So positive feedback will be created experimentally. For example, if we see in an ideal op amp, what will be the gain? Gain is infinity. So gain is infinity means if we want to get the lesser gain, what we have to do? We need to apply the feedback. That is, with negative feedback, we can reduce the gain of any type of amplifier. So as the gain is reducing, the stability of the network will be stability of the network will be decreased. Why? Already you have learned that in a transfer function, if the poles lies on the left hand side plane, then the stability of the system will be more. If any one of its pole lie on the right hand side, so then the system stability will be decreased. So in the same way, here also we are having two types of feedbacks: positive feedback and negative feedback. So let us study in further what are the advantages of using negative feedback and what are the advantages of using positive feedback. So here let us study each block in detail. So first one is nothing but first block represents the signal source. This block is either a signal voltage in series with RS or a signal current in parallel with RS. Suppose if the input is voltage, then source resistance must be connected in series. If the input is current, then the source resistance must be connected in parallel. Next, coming to feedback network. So actually it is a passive two-port network which consists of resistors, capacitors and inductors. Mostly it is a resistor network. So this beta is different from, that is beta, that beta represents the current gain of transistor in CE configuration. So this beta is different. Here this beta is always less than 1, whereas the beta in CE configuration represents current gain, DC current gain, which is like more than 1. Next, coming to sampling network, there are two types of samplers. One is voltage sampler and the other one is current sampler. In voltage sampler, the output voltage is sampled by connecting feedback network in shunt across the output that will be shown in further slides. Okay. Similarly, in current sampler, the output current is sampled by connecting the feedback network in series with the output. Okay. So, like we can sample two types of parameters, one is voltage and current. So, how do we say the voltage is like applied to the feedback network means depending upon the connection of sampling network. So, for voltage the connection must be in parallel, for current the connection must be in series with the feedback network. Next, coming to mixture network block. So, there are two ways of mixing feedback signal with the input signal, that is series input connection and shunt input connection. In series input connection, actually series means name itself it is saying the output of feedback must be connected in series to the input of the basic amplifier. So, whereas in shunt connection the output of the feedback must be connected in shunt with the input of the basic amplifier. Okay. Next block is basic amplifier. So, basic amplifier we can say gain or transfer ratio. A represents gain or transfer ratio. The symbol A represents the ratio of output signal to the input signal of the basic amplifier. So, here what is its output of the basic amplifier? V. What is the input of the basic amplifier? Vi. So, V by Vi is nothing but voltage gain. So, which is denoted by AV. Similarly, output current is I and the input current to the basic amplifier is II. Therefore, I divided by II is the current gain. So, denoted by AI. Next, I divided by Vi is nothing but transconductance denoted by Gm. V divided by II is nothing but trans resistance denoted by Rm. Actually, Gm or Rm does not represent amplification. Therefore, these are referred as transfer ratio of basic amplifier. We use A to represent any one of these quantities. Similarly, the symbol AF is defined as ratio of output signal to the input signal with feedback. What is the output signal with feedback? V0. What is the input signal? Vs. Therefore, AF is defined as ratio of output voltage to the input voltage. Hence, AF is used to represent any one of four ratios, that is AVF equal to V0 divided by Vs, AIF equal to I0 divided by Is, GMF equal to I0 divided by Vs and RMF equal to V0 divided by Is. So, this is about the explanation of each block of feedback amplifier. So, now you can see what do you mean by feedback. Process of injecting a fraction of output energy of some device back to the input is known as feedback. So, just now you have seen in the block diagram. So, the part of the output is giving back to the input that forms the feedback. Some of the shortcomings or drawbacks of the amplifier circuit are. So, actually why do we introduce negative feedback means there are some drawbacks. What are they? Let us see. So, change in the value of the gain due to variation in supplying voltage, temperature or due to components. So, we know that gain depends on VCC, temperature and components like IC0, VBE and beta. So, with this gain also changes. Distortion in waveform due to non-linearities in the operating characteristics of the amplifying device. So, at the output distortion comes, that means exact sign, the shape of the output will not be same as the shape of the input waveform. There will be some distortion due to non-linear characteristics of the active device, that is nothing but transistor or FET. The amplifier may introduce noise. Okay. So, amplifier may introduce noise. The above drawbacks can be minimizing if we introduce feedback. Okay. So, all these can be rectified if we introduce feedback. So, there are two types of feedback amplifiers. one is positive feedback and the other is negative feedback. Positive feedback is also known as regenerative feedback. Negative feedback is also known as degenerative feedback. So again, negative feedback is classified into two types, voltage and current. So we are having voltage series feedback, voltage shunt feedback, current series feedback, current shunt feedback. So all these are nothing but negative feedback amplifiers. So what do you mean by positive feedback? Just now I have explained you. So if you look at this diagram, so it consists of amplifier introducing 180 degrees phase shift, and there is a feedback network introduces 180 degrees phase shift. Okay, so total phase shift of the loop will be equal to 360 degrees. See, when the feedback voltage or current is in phase with the input signal and thus aids it, it is called positive feedback. So when the feedback signal is in phase with the input signal, so here you can see the arrow, this is nothing but input signal and this is feedback signal, both are in phase. Both are in phase means both are starting at the same like at the same point, that is nothing but same phase. Both amplifier and feedback network introduce a phase shift of 180 degrees. The result is 360 degrees phase shift around the loop, causing the feedback voltage Vf to be in phase with the input signal Vn. So in positive feedback, so therefore if we see the phase shift around the loop, it is nothing but 360 degrees. If the feedback signal is in phase with the input signal, then the feedback is known as positive feedback. Now coming to negative feedback. So here there is the amplifier circuit which introduces 180 degrees phase shift. Similarly, feedback network which introduces 0 degrees phase shift. See, here input is this one. When it is introducing 180 degrees phase shift, so here there is the inverted output. Okay, so inverted at its output. Similarly, in the feedback network, 0 degrees phase shift means, so there will be no phase reversal at its output of the feedback network. So if you see, if you compare input signal and the feedback signal, they are opposite to each other. Means when the feedback signal is in out of phase with the input signal, then such type of feedback is known as negative feedback. So the same points have been written over here. When the feedback energy, voltage or current is out of phase with the input signal and thus opposes it, it is called negative feedback. If already I have explained you, amplifier introducing 180 degrees, whereas feedback network is designed such that it introduces no phase shift. So negative feedback is also known as degenerative feedback. So just now, like I have explained you, in negative feedback we have 4 types of amplifiers. In negative feedback we have 4 types of amplifiers. One is voltage series feedback, second one is voltage shunt feedback, third one is current shunt feedback, and the last one is current series feedback. So in voltage series feedback we can see output is voltage and the input mixing is series. Whenever output is voltage, therefore the connection must be in shunt. So whenever the mixing is series, therefore the output of feedback must be in series with the input of the basic amplifier. Then such type of feedback is nothing but voltage series feedback. So in voltage shunt feedback, if you see the connections, output is voltage means there is nothing but parallel connection, and input is shunt means then also it is nothing but shunt connection. So in current shunt feedback, so output is current sampling means, therefore the connection must be in series, that is the feedback network must be in series with the output of the basic amplifier. Shunt means the output of the feedback network must be in parallel with the input of the basic amplifier. In current series feedback, in the same way, the output is like current means the output of the feedback network must be in series with the output of the basic amplifier, and the output of the feedback network must be in series with the input of the basic amplifier. So this is about classification of feedback amplifiers. So With this lecture is completed. Thank you.